we are having, sorry, because I have people asking me to come in at the same time. We are having a session with Professor Fábio Silva. This will be until 10 minutes to 10 a.m. And he will be speaking about augmented reality learning in higher education. So thank you, Professor Fábio, for being with us. It is a pleasure to count with other teachers from other faculties from the Polytechnic of Porto and have the opportunity to listen to you share. And on the second part of this morning session, we will be with Mr. Celestino Magalhães, who will be speaking about augmented reality in education and training.
First for children.
Yes, in basic education.
In basic education.
Okay, so I'll interrupt my sharing now in order Professor Fábio can share his presentation while I'm giving permission to other persons who are waiting to come in.
Okay.
Progress. I'll take my micro now.
But I cannot share my screen. I don't know why. I think that
Inês has to authorize it. Just a second.
Okay, I can now, right? Sorry. Okay. Okay, everybody can see it, right? So I'm going, I was asked to talk about augmented reality applications and their development. I'm going to talk about this, what you can do, what options for the development of augmented reality applications, and I'll try to show some mini examples. So about me, I am a professor at Polytechnic of Porto. Okay, I'm also an integrated researcher at the research center CCSE, and I've been lecturing in the last years the subject virtual and augmented reality in the Master's Engineering of Informatics. So, and I also have some research activity in this area. So, what we mean by well, augmented reality is the generation of computer images or virtual images and the projection of them in the real world. Okay, the interaction of the virtual reality in the real world. So there are many definitions for this. These are just two examples from the English dictionaries, and they toy with the idea of bringing some computer-generated image to the real world and to allow interaction or some interaction with them. So ideally, it would be natural interaction, but it's not always possible. But at least to have the confusion between what's real and what's not. So over the years, augmented reality is a term that has picked up quite interest in the population. We can clearly see that by the trends in Google research that augmented reality is actually superior to virtual reality. So there is an appetite for these kinds of thematics and applications. And actually, in most of the developed world, people seem to be moving on from virtual reality to augmented reality. Okay, inclusive in Portugal, where it's one of the it's a term more searched when compared to virtual reality. So, what is the development of augmented applications? Well, we have been doing some kind of augmented reality apps from very early on. Okay, we can see by the late 1862 that there were some clever mechanisms to project virtual images onto a stage, okay, using glass and the clever use of light. So we can see that in the real person is at the bottom, hidden from the public, but the image is projected through a set of lights and mirrors at the upper stage as a ghost. So that will be some initial beginnings of augmented reality, which means placing something where it is not. Of course, this is not augmented reality that we are talking about right now. And we can also see that movies and fantasy also deployed quite a contributions to what augmented reality could be. We can see in movies from science fiction that it would be ideal to project holographic people into the environment and to allow natural interaction with them. Unfortunately, we are not quite there yet. We cannot do as is, but we can use devices like head-mounted displays and cell phones to achieve a similar result, although with dedicated hardware. So today's applications of augmented reality, we can find some games, of course, but there are a lot of professional applications, and their benefit is mostly in the business cases and the industry, where we can have a screen that combines both the reality and virtual elements that add some virtual representations or virtual objects on top of the real environment. So we can see like something that points out some locations on the street on the upper left corner. We can see a mechanic that is getting detailed instructions through virtual objects in the left inferior corner. We can see an architectural application in the right upper corner, and we can see a shopping assistant in the right bottom corner. So what augmented reality requires, okay, is the processing of the input of the real image, okay, that we have, the real world, and the tracking, accurate tracking of virtual objects, okay? So if we place any kind of image or 3D model in the environment, we need to process and track its position. And we have no means of openly projecting it on the environment, so we need a display, and you project the real world and the virtual objects upon that display. Of course, we have some problems to solve. Okay, in case of if we had virtual objects, we need to estimate their depth, their light, their reflection. We need to detect real objects to see if we need to make some occlusion to create the illusion that an object is behind some real object. We need to process the virtual objects in 3D, and we need to synchronize this whole experience between what's real and what's virtual. So, and this is mostly the realm of computer vision, okay? Augmented reality needs a lot of computer vision algorithms to work properly, but most of these problems have already been solved, at least with common hardware. And we can actually use all these, let's say, algorithms and concepts quite easily using modern development frameworks. So before jumping to how can we actually develop, we can give some examples of devices, okay? We have what we call head-mounted displays that are displays that are placed in the head of the user, and traditionally they can allow to see through the screen or through the lens, and yet at the same time project some virtual objects or visual representations in the lens. So in this case, they would be see-through. We can see the latest hardware from Apple that actually is an augmented reality application, but actually is a occluded device, okay? Because there is a screen in front of the eyes of the user, and there are a lot of cameras filming the exterior and projecting it on the screen. So the person is totally occluded. However, the experience is quite nice because it's really fast and has a very low latency. A more common hardware to see augmented reality applications is with mobile phones. Okay, here is the screen of the mobile phone that does the mixture between real and virtual. So we can see that quite easily in the Google Lens application that not only can film and take pictures of the real world, but also alter the information in the real world with virtual representations, like to translate the names of cities and streets. We can also see the Snapchat app, the Filters app that you can see most commonly in most messenger applications. And in the case of iOS, in the left right corner, we can also see an application which is Clip Drop in iPhone, which allows to take a picture of an object, and the application itself will try to make a 3D model from the object that was taken picture, and we can actually copy and paste it to a 3D modeling software. So this is some applications of augmented reality. So we can also debate about augmented reality between strong and weak augmented reality, okay? And we can see this like in the popular game Pokemon Go, which is a very weak augmented reality because it has not sense of depth. Okay, the virtual object is just projected in a position of the screen. It does not detect the planes of the real world. Okay, what is horizontal, what is vertical, if there are objects. There is no processing whatsoever. It's a nice illusion. On the other hand, if you see a demonstration like this from Microsoft, which is, I believe, the game Minecraft Earth, you can actually use a smartphone or HoloLens to play in your living room. And if you see clearly in this picture, he identifies exactly all the planes or horizontal planes, okay? The table, the couch, and the floor. And it represents the virtual objects on top of these real world elements. And when you play with this in mind, okay? So a piece can drop from the table to the floor, and there is all this perspective, and when the user moves around, everything is rendered in perspective. So that's a much nicer experiment. So what I do with students in the higher education is actually try to give them tools to devise applications in strong in the strong sense of augmented reality, okay, that respond and recognize the world that they are in. Of course, well, we can have more definitions like weak and strong AR. it's inaccurate tracking, which means that the object placed, it's not following any real world common sense. There is limited interactive, and on the stronger AR, we have accurate tracking. When we place an object in top of a table, for instance, if we move around, the object stays in the same position, but changes the perspective to like a real object would. And of course, natural interaction would be nice, but even if we do it through the mobile phone or the screen of the mobile phone, there is some interaction that is correct according to the physics laws of the environment. So we can see some other applications that we can also make augmented reality applications based on GPS and compass tracking. Okay, not necessarily a camera, but we can attach some elements to GPS coordinates and then display it on some screen. Most commonly, we can use cell phone, but there are other approaches, like in the bottom right corner, which is a dedicated clothes. It's a person trying clothes in a augmented screen, which ideally it will adjust the clothes size to his stature and to his posture and body type. So this is one of the applications that you may see in some stores. I believe that there are some stores that already have this application. Okay, so how do we come about to develop these applications? So in fact, there are a lot of resources available to build. Okay, more and more the expertise needed to have a functional product is decreasing, especially with smart assistants. Okay, like ChatGPT and the others. There are a lot of frameworks with the approach of low code, which is not too much technical expertise. You just have a building blocks of an application. You can mix all together to create a viable product. So, and actually, augmented reality is not necessarily too new. There are already a lot of frameworks from for mobile development, okay, for device development, like any device with augmented reality has traditionally an SDK or a software development kit that helps the development, and we can actually develop with open standards like web standards from WebXR and Unity game engines, for instance. So there are a lot of options. Okay, these are not all the options available, are just some. And in the case of the Unity platform, it's like an IDE, development environment, which allows us to develop augmented reality apps. Okay, not just games, for a multiple range of devices. Okay, we can develop for computer, for headsets, and for Android and iOS devices. So what's good about this is that it has an approach as low code. We can just drag and drop some elements and have a minimal viable application that does something in augmented reality. So in terms of architecture, this is just a library or umbrella of tools that we can in some way program, and then it can generate programs either for iOS or Android device, for instance. So there are a lot of let's say algorithmic support. Okay, so in this case we do have multi-platform support. We have automatic plane detection through the camera of the device. We have feature point detections, which is special points inside the environment, light detection, heat testing, which means knowing if a point is in a vertical or horizontal plane, anchors to put some virtual object and make it stick to where we put it, even when the camera moves around, image tracking, 3D tracking, world maps, face tracking, and a lot of characters. And it has 5 libraries. Some are generic, like the first 3, and the first 2, and the last 3 are device specific. So generally, we develop with the first 2, and then the program compiles for the device. So here is a new table which shows augmented topics in the left, and its support in AR Core means Android, AR Kit means iOS, and some other devices like Magic Leap and HoloLens, which are head-mounted displays for augmented reality. Okay, you can see here the same with a little bit more detail. So when we are developing in a framework, we can actually consult these tables and know what are the capabilities of our applications could be right out of the start of the project. And if it is not something that we need is not here, it does not mean that we cannot implement it. It means that we don't have assistance from the platform or from the framework. So it means that we have to develop manually, which can be problematic. So it's better when the future is already supported by the framework. So what are the most common tasks that we do? Okay, which is create and insert virtual objects, depth estimation, and light estimation. Okay, so when we create a virtual object, we want it to insert it in the correct place, okay, and have a notion if it is on a horizontal plane, and if there are horizontal planes at multiple heights, and if there are objects like, for instance, a table, and I place the virtual object behind the table, that it hides part of the object to create the illusion that the virtual object is behind the table. And when I put the virtual object, that if I move around, the object stays in place, okay? It's just corrected the perspective. Of course, there are other implementations, such as
Can you switch off your microphone, Celestino, please?
Detecting specific objects in the scene, like faces or any object dropped in the real world, and we can actually also save virtual objects. Like we devise an experiment, we place virtual objects in the environment, and there is a problem when I switch off the device. Okay, when I turn on, it's not easy to place the same objects in the same locations. However, the Unity and Google provide libraries that detect where the objects were last placed and recreates the virtual objects in the real world, even if after shutdowns from the application. So from a more practical approach, and to show you some examples, so just to show how easy or difficult it can be, for instance, to use this Unity game engine to develop augmented reality apps, we can just create a project. Okay, this will be summarized, of course, but to give you an idea, Unity has nice guides for this. Basically, we have to import the necessary libraries and select the deployment device and build a game scene in the Unity framework. Okay, the most basic one that you can do, we have special objects that you can import to the editor, okay? It's just drag and drop, like the IR session origin, and IR camera, which are the three main components that will process what is seen through the camera. And we can add the functionalities from the list of supported functionalities. In this case, we can add a plane manager, which is everything that comes through the camera goes through this library plane manager, and actually it creates a virtual representation of virtual planes like walls, floor, top of desks, chairs, and it creates a mental map of planes. And we can actually use a raycast manager to place objects on top of those planes in the real world. So a raycast manager would be like pinpointing a place where we want to put an object, but we can actually force the object to be on top of a plane, on top of the floor, on top, or placed in the wall, and we can configure that. So I will try to show some here. Okay, I hope you can see what is an application made with Unity. So in here, a student, you see these black lines.
Yes, we can see.
The recognition of the floor. And you will see then that you will also recognize the table. Okay, of course, tracking depends on the quality of the device, but it is trying to put here a table, and you see that it's actually auto-corrected for to put a table inside on top of the table. A table is on top of the table. Okay. And you can see that it's trying to move about the object, but the object is moving in this plane. Okay, it's not being misconfigured. It's moving around, and when the object is fixed, we see that it's being occluded. Okay, so of course there is here a little imprecision in the plane detection, but we see that the object is actually being occluded on the corners, so it behaves like a real object would behave. So this is the expectation. Other oops, sorry. Sorry, it came to the beginning. Go there. Oops. Okay. Another traditional demo is like recognizing a virtual queue in the environment, like a card or a code or a QR code placed somewhere, and not only recognizing that image or that virtual queue, or the physical queue, and displaying a virtual object inside. Okay, we can actually do this very easily in also Unity using the reference image library, selecting the image that we want to use. Traditionally, it should be an image with enough distinctions. Okay, it cannot be just a white board. It has to have some detail to be recognized. But we can use very easily a QR code. And we actually just import the library, drag and drop the image, and in the image library that we created above in one, and the virtual object that we want to place in two, and actually the application will be able to find this P in the environment, and when it finds, it places the virtual object on top of that. Okay, this is a very common use case of augmented reality, and you can actually, let me try to show it again. You can actually see it also developed in here. Okay, with local queues. You'll see that the application recognizes a handwritten to from the student and places an object inside. Okay, what it is doing now is making a scan of the object to save it for when other people come to this virtual queue, see the same object, so it will alter the object and it will always be saved there. And it can actually save multiple images and have multiple objects. So it will transition from this one to another, and it will show some animation and show a different model. So what it is recognizing is these 2s and 4s that are they were handwritten, taken a photo and put on the system. So this is some of the things that we can do. So sorry, let me see here. So what else can we do? This is using the Unity platform. Okay, we do have more tools available for us, like machine learning models. Okay, which are models that learn how to classify what is being displayed in the screen. Okay, we have these models. They are not traditionally programmed in the sense that we have the data in the program and we make something, an output from these two. Usually we have the data, which is the images, and output, which is annotated images. And we trained an algorithmic procedure to generate a program. Okay, and this program is what we call a deep learning model. So traditional deep learning models use a model called neural networks, which is a set of matrices or weights, connections and matrices. And we see that like that image, which means a 6, is each pixel is an input from the yellow layer. Okay, imagine that each pixel is one of these yellow points. It goes through a matrix of numbers and it produces an answer in the orange part. Okay, usually it will produce a 1 in the 6th orange ball and 0 in the others. So this is to have a common sense of what happens here. It processes all the pixels from an image and outputs a category or lines around the image that we can use to classify things. So this is, each point has this structure, which is a neuron. This is a representation. It is represented by a set of numbers and matrices in mathematics. However, we do not actually need to know exactly how this works. We do have trained models that are an evolution of that simplistic model from neural networks that take an image or video and output detections or categories in the image. So this is an evolution of neural networks called convolutional neural networks that spawned a lot of interesting models for use in augmented reality. So we can see some of the object detection algorithms like YOLO. This is a very old YOLO. There are the version 8 currently, but what it does, it sections the image, tries to find possible candidate regions to where a real world object is, and then it selects the best regions and gives a classification and a confidence level to the classification that we have. So in here you can detect the dog, the bicycle, and the car. Actually, training these models is quite expensive. Okay, it takes a lot of time and energy to do so, but making questions, once the model is training, making questions is very, very fast. Okay, and we can do it very, very accurate. So and also we have libraries that we can use to develop this. Okay, but what's interesting, if you want to learn more about these models for your applications, is this this website, like the TensorFlow library, has a library for mobile and web development. So you can use the camera from your computer from your laptop or desktop and try out some of these algorithms. Okay, some of these algorithms will detect your position, like an old kinetic sensor device from Xbox, but using just images, will detect the position of your fingers, will detect what is around you in the camera. Like if you pick up a pen, if you pick up a notebook, it can actually find those. And there are models for most of the tasks that we want to do in augmented reality. Okay, from person, the object, generic object detection, and the position of the person, body segmentation, and let's say, oops, like, let me just try to show you this page. It's if you search TensorFlow lead, you probably can get there, but I would like to just to show you to get a updated version of these. Okay, so these are models, and these are the types of problems that you can solve. So working with images, working with audio, classifying what we are saying, with text, depth estimation in general. And some of these models have here a live demo. Let's try to see this one. It will ask for the camera. My camera is not working, but what would have appeared here is a representation of our hands. Okay, this development is anyone who knows how to work with basic website development, basic web development can use this. Uses pure JavaScript, and I can show you here some output from students. Okay, that made a basic application recognizing certain objects in the scene. You can see in the upper right corner that it's detecting the hand of the student. Okay, is using hand gestures to navigate on the page. So then we will use the camera. It is using the camera. This is a web page, and it is using the camera from the computer, and it's trying here some different models. Okay, that is looking at a person. Its points is trying to identify its limbs. It's like creating a filter over the person, and it will also try to take some objects from from the environment, like this in the mouse, and is substituting from the car wheel. So it will try to simulate the repairment of a car wheel with a mouse and a cell phone. So the tire is the cell phone, so it's placing one above the other. Of course, this is a very limited experiment, but you see that it's using multiple of those models. Okay, it did not train them. It is using things that are already trained and deploying it in live on the application. Of course, a real world application would be just the final result with the filters and things associated. I just want to say that this is actually the result of using some of those models that I showed you previously. So coming back to the presentation, these are some of the models that, well, if you take notes, you can try to look. And one last thing that I would like to show you is that there are a lot of things that we can do with augmented reality. Okay, I've just touched in some of them that are being actively deployed, that I use as exercises in classes. And there is actually this a close related subject, which is this photogrammetry, which is our programs. Sorry, this is in Portuguese, but it's programs to analyze photos and recreate 3D representations of the real world. So what we do is we take like multiple photos of real world objects. We import it to a specific software. In this case, is Alice Mesh Room, I think. And it not only maps spatially where the photos were taken, as it reconstructs the photos into a 3D object that we can use in augmented reality as a virtual object. This is enabled by a lot of mathematical developments in perspective, in depth estimation, and object recreation. But actually, what the software shows is like when we take several photos of a static object, it not only shows where the photos were taken, it starts to build a point cloud, and then it will generate a possible model from what is on the left and what is on the center in the right. Okay, any of these like mini cameras is one point where one of these photos were taken. It's trying to estimate exactly in space where the photo was taken, and it tries to reconstruct the real world object into a virtual object that we can use then in applications like avatars or something. Okay, this is one of the oldest softwares today. Especially the advancement of artificial intelligence, this is becoming much faster, and it does not need this kind of dedicated software to achieve the same results. So these are some of the things that we can do in the field of augmented reality. This is what I was preparing for today. I hope that it is of interest for you. And if you have any quick questions for me, please do so. I finish here my presentation. So I don't know how.
Thank you very much, Fabio, for a wonderful presentation. I was here learning several interesting things for me. I don't know if the floor has any question, but if you don't mind, I will do one, and forgive my amateur sense of these new concepts for us university teachers from other fields. I didn't understand what is the concept of foundation and the concept of libraries. Can you help me understanding what is that?
When you develop a program, we have a program that makes programs, okay? And in the case of Unity, it's a program that we can drag and drop elements to try to combine them into a working solution. So these elements are normally in packages that we call libraries. So we say that in our application, I need to, for instance, detect planes. So I drag and drop that library to my project and use it. Okay, just to configure it. So and foundation is the base library for everything. Okay, so in Unity software, I import that library to state that we are creating a mixed reality app or augmented reality app. And from that nuclear library, I import the other elements that I need my application to do. In the case of Unity, it's like this. In others, well, it differs a lot, but Unity is a low effort platform that you don't have to be an expert in programming to easily do something.
Okay, thank you. Does somebody has other questions here to Professor Fabio? And
Um,
is he, yeah?
Fabio, excellent presentation. It was right on the spot, what we want. Just a question about licensing of these platforms. Of course, some are free, some are not. The GitHub and Light, I think, are open, widely open. But about Unity, what is the model of licensing? Probably people will be interested in knowing.
Okay, if you're building applications for commercial deployment, and in the case of Unity, it's free until you reach a certain profit, I
Okay.
believe, or a certain number of installs, typically in the range of hundreds of
No,
thousands.
it's not important
But,
to understand people, just to say to people how it works, okay? Because
most of the machine learning models that I showed here, especially this last part, is open source, so anyone can use those models. But they are lower versions of the big models that companies use, and those are paid. We need to contact the companies that are building those models. For instance, these object detection models, they work pretty well, but they do not classify everything. There are a lot of missing points. If you have expertise, you can train these models to detect more things. But the companies and research teams that do these kind of models have much bigger models that we can use. For instance, it's the same problem with things like ChatGPT. Okay, if you want the big model with the most correct answers, you have to pay OpenAI a license to use it. If you want something that does like 80-70% of the work, there are already open source models like these ones that do that. Okay, they tended to be a little bit more error prone and not as accurate, but if you want to show something, they can do it pretty well.
So now, as I shown in the beginning of this session, this second part of the morning to the students' course will be up to Professor Celestino Magalhães and Ricardo Silva, which I thank both for the presentation, these next 50 minutes of presentation. And I won't take much more time and give you both the floor. Thank you very much for being here.
Okay, thank you. Good morning to all.
Good morning, everyone.
Me and Ricardo Jorge from the team and Professor Celestino Magalhães are going to speak a little bit about augmented reality and education and training. But before we begin, we kindly ask all of you to download to your phone this application, because it's going to be used during our presentation, in the second part of our presentation. So it was nice if, as it is an applied project, should you have on your phone this presentation. It has nothing to do with the bear that we saw yesterday in João's office, but is also three-dimension bear is the application.
I just share with you at the chat here at the Zoom session the links, direct links for Android and for iOS to install on your phones or tablets, because this app runs on only on smartphone or tablets.
Okay, it's clear.
Yeah.
it's not, I already did that.
Okay, you are going to have time, because our agenda, let me see, as these 4 topics. The first 2 are going to be presented by me, and the other 2 by Professor Celestino Magalhães, and it's in point 3 that is going to be needed and deeply. this application for to accompany the presentation of Professor Celestino. It is going to be an applied situation.
Sorry, before the beginning, Professor Inês,
Yes.
you give me permission in both of my connections, because one of the connection is the computer and the other is smartphone, that I will share the screen with you when I will use the.
Okay.
Okay,
Can you
thank
check
you.
if they are both already?
Oh, yes, I have both now as permission.
Already?
Thank you. Yes,
Already?
yes, already.
Okay, so our agenda for this hour is going to be divided in these four topics. As I said, the first one is going to deal with the trends of extended reality at university level. And the second one is a very small point to recover some of the aspects that João has emphasized yesterday about the extended reality and the experience related to extended reality, but now concentrated in education and training. Afterwards, the third point is going to be how can students exploit or use, as you see there, use to take advantage of this augmented reality. And the fourth point, also it show a lot of cases where we can use personally the augmented reality and the tools that already exist on the market. So to begin to analyze the trends in extended reality at university level, I brought here a survey. We brought the survey from University of Newcastle that it was publicized in 2022, and we are going at this moment to analyze it from the students' perspective. Afterward, we are going to recover it again and analyze with the teachers' insights, to see some teacher insights. But in the students' perspective, as we can see, we are going to analyze it a bit divided in general attitude, the concerns, point B, and point C, the perceived capability to enable teaching. In general attitude, as we can see, students also consider that extended reality is going to be a powerful tool, and they are open to it. They don't see that they are not very preoccupied and worried about the distraction that can happen with this kind of techniques. And also they don't feel that is a fashion or a passing trend. They don't feel it as the general attitude towards this technology. They think that is, as in graph B, they think that is becoming a standard to teaching, as a teaching tool very strongly. Students, as you see here, approximately 60% of them thinks that is likely or very likely that extended reality is going to be a tool for university teaching, and it's going to happen in 5 years' time. So it's not to be very long. It's going to be in the next 5 years. This is analyzed at the University of Newcastle. So they think that in the next 5 years, University of Newcastle will integrate extended reality on their activity, teaching activities. Let me. At the graph B, as we can see, there is not many concerns by the students. It's also the gray, always the gray area, the students. You see, they are not very concerned, preoccupied with it. As you see, 63% don't see any problem with it, and only the other 37 see some kind of concern, show some kind of concern. What are the biggest concerns that they see on this technology is they are related to infrastructure and support, and also the impact on teaching and learning. So these are the two main concerns that they generally have. And they speak also about the barriers that can happen. The barriers, the strongest one, the four strongest one are related to funding, the investments that are going to be needed in technological devices and software. So it's a concern for them. For all, this is for all. There is not this separation between students and the other staff. So the main barriers is unite analyze it. It's related to funding. It's related to support and content refinements. It's also related to what teachers is going to deal as the rules of this technology and should be verified, and also it's all also has to deal with the software and development procedures. This is the main barriers that they see and makes them the highest concerns of all. I have here, okay. The final analysis is to see how the perceived capability, because they are not things with using so often this technology, so it's called the perceived capability to enable teaching. And as we see, the students here, we can analyze the students' position. The students' position as a whole, they are very confident in the use of extended reality in teaching, in education, not only in factual knowledge transfer, but during the process also of learning, the procedural training activities with high risk and high costs. It's one of the highest where they see they are more confident that is going to be used about this use. Also, the flexibility that this technology puts in delivery contents, it's also an important one, the highest one. And afterwards, all other are have important scores from the student's perspective. Effective education, the standardized delivery of knowledge, and the standardized assessment of knowledge. So in all of them, as we can see, it passes the outweigh, and statistically so, it induces us to consider that the students are by their side, are very open to this, not only to this technology, but also to the benefits that they are going to have with it in the process of learning. The second point of my presentation has to deal, let me, this past, I have here, okay, has to deal with, to recover some points of previous presentations of the previous days, has to deal with the benefits. First of all, augmented reality is going to give the possibility to people to interact more closely and more globally and collaborate also with no kind of physical constraints and locations. it opens a possibility to share knowledge in diverse contexts, what is also very important. And with the process, when we speak about education and training, it provides a very strong hands-on experience. Not only we put here with complex machinery, but also in complex subjects like surgery and things like that. So the benefits are important, but we also have to look that there is technological needs associated with this technology. And as we saw, the needs goes from devices, smartphones, tablets, portable computers, other kind like the head-mounted displays with hand-free experience, softwares, and also from the technological need, a point that also João has referred yesterday, the cybersecurity, and we are going to deal with it when we speak to teachers in the next presentation. We at this moment we saw in the beginning that in 5 years' time it's going to be more used than today, but we have today very strong uses in education, not only related to knowledge, but also to competencies and skills. These are some examples of its use already in engineer education with virtual labs, collaborative learning, and immersive design and prototype simulations. Medical training and education also with surgical training, medical procedure, diagnosis and treatment. In space technology with space environment, with virtual experience, for instance, in international space station also. In mathematics, visualizing mathematical concepts. We are going to have an example of this in the third part. In art and humanities, related to virtual museum tours, historical places, virtual visits, interactive storytelling, artistic creation, and multicultural experience, but also in general education, in language learning, soft skills, professional training. This are a lot of examples that we have already, and a lot of them we are going to cover during the presentation of Professor Celestino Magalhães. That I pass to him the word at this moment. Thank you to be with us.
Okay. I don't know if you are listening me well, because I'm talking for the computer of Professor Ricardo. I don't know if you want me to change the sound for my computer.
No.
No, it's okay. It's okay.
Okay. So just stop the presentation that I present from now. You could stop. I present from here. Okay.
Okay.
Okay, I will present now from my own desktop. Okay, just a minute.
Celestino, agora pode ligar o microfone que o Ricardo.
You can put your micro, please, Celestino. Ricardo switch off already. Thank you.
Okay. Good morning, everyone. I think that now you are seeing my, but there are some echo here, right?
No,
No.
only for
Okay.
you. And we're seeing your presentation. Thank you.
Okay. Good morning, and I wish to thank you, Professor Ricardo, for the invitation to being here with all of you today, and we will see some practical aspects from using the augmented reality in education, in practical education. And we use this particular tool, 3D Bear, because it is a very easy tool to use, not only for us as teachers, but also for the students. And you will see that you could use their own devices like smartphones or tablets to make the exploration of learning activities. But us as teachers must as this aspect attention to this aspect, because we have some pedagogical characteristics that we must be advised and we take care before using this technology inside our classrooms with the students. And this is my first approach that I will share with you. Why we could use these learning tools or these emergency technologies inside and put them inside our pedagogical practices. Beginning with Bloom's taxonomy, I think that all of you just have some contacts with this taxonomy at some point of our careers. We know that the higher levels are the levels of higher order thinking, where the students have to apply the knowledge that they produced during the curriculum that we taught to them, and they have to explore that knowledge when they are creating, where they are evaluating some situation, where they are analyzing a problem, a practical problem, and they have to find the solution to create solution. And with these new technologies, we could explore some of the skills, the competencies that we all are been talking today and the prior days, that is like creativity. If you use student-centered learning, and today, nowadays, the focus are our students, so we have to give them the freedom to expand the creativity and explore this creativity through the products they are producing. Among these, we have critical thinking, because we are stimulating our students to think about the process, think about the problem, and find the solution together. And now we go to the point 3, communication, because when they are working together, they have to communicate with the partners. They have to communicate with the colleagues to show their thoughts, to show their ideas, and together find a solution for the problem. And these 4 skills, creativity, critical thinking, communication, and collaboration, are the meaning skills that will produce meaning and meaningful learnings experience to our students. So why use 3D Bears or the pedagogical model of 3D Bears? First of all, to engage our students, show the students they can succeed using these tools inside the learning process, develop confidence and perseverance among the students, have superior use of these immersive tools inside an immersive space or an experience, a digital experience, and also motivate students to continue evolving in their learnings and to continue producing meaningful knowledge through their careers. To learn, because they will explore new concepts, new procedures, and information using these new tools, where they will apply these new tools to solve real-life problems, not only the problems that they saw inside the classroom, but they will also realize that these problems came from real life situations, and they could apply this knowledge to solve these problems. And they could use online customized labs and hands-on activities, because they will use their own devices to produce these products and to apply the knowledge during this process. And the most important of all, this is the situation that they are learning by doing. They have to put their hands in the problem and create put the knowledge to create the product. Among the master, we have using or our inside the teacher process, we use advanced design and problem solving. We stimulate the higher levels of Bloom's taxonomy, apply, analyze, evaluate, and create using these tools, augmented reality and also virtual reality or extended reality. And after that, we have stimulating the critical thinking, because we have to ask the students to make some inquiries, to reflect, to access, to among the practice that they did, and self-direct this learning process through the curriculum they have to achieve and learning objectives they have to achieve. Also, we are developing lifetime skills, not only for that moment, but these skills will be permanently acquired by our students. So, what are the steps for implementing this design thinking in our classroom? First of all, the accept. Our students must accept that a challenge is posed for them by us, and this challenge is related with what they are studying. We are promoting research, because with this challenge, they have to search for academic principles, practical issues, the background of the curriculum. And when they are searching for these aspects, they are also working in the solution of the problem, or this search will be made individually or in small groups, where they could discuss among them what are the way, what will be the trip they will do to find the solution for the problem. They must discuss, they must define what will be the outcomes, what will be the objectives that they want to achieve. They want to think critically with the potentials on the potential solutions, and of course some obstacles that will appear in this way, and they have to solve it or find the solution to solve it. They have to make decisions, because not all of them have the same idea, not all of them have the same opinion, so they have to communicate, they have to explore and show their own idea and defend this idea to together find only one idea that will be the answer for all the group. They will do this by composing, by working on that. They have to make some projects, made some line of action to together find the solution that will appear, they will show that this solution will solve the problem that will bring to them inside the classroom. They have to build the learn by doing, like I told you before. They have to build a model, a solution, a storytelling, a digital narrative, whatever, to show that that solution will be solving the problem that we present to them. After that, we could explore the critical thinking, about the presentation that we'll be doing of the work that they have done, and we could reflect together, not only us as teachers, not the students that produce that work, but all the classes could explore and present their ideas, their opinions, and bringing here a discussion together to profound even more the knowledge that we produce it. Okay, so getting the digital thinking, we just view that this design thinking fits a good pedagogy because we have these three dimensions: engage, learn, and master, where we could decompose in sub aspects that are related with these dimensions. Engage, the student must accept these learning tools and these challenge that, thank you, this challenge that we propose about the learning. We have here some sub-dimensions that we recognize that they are essential for our students to produce the knowledge, research, discuss, decide, compose. And at the more higher level, they have to build and present and made some reflection about the work they have done. So after that, we could see that some of the tools that we could explore using this technology, passing by the class discussion, working through problems or concepts, guiding study. So these higher levels are the most meaningful, or are these the tools that are most helpful and meaningful for the learning of our students. But better than talking to you is showing to you the tool. I will leave this for in a few moments. And now I will stop my presentation and my sharing from here, and will share my screen from my mobile phone to show you the practical use of this tool, 3D Bear, and how could I compose and made some activities with our students. Let me just share my screen. Just a few minutes. I think that in a few moments will appear in your okay?
Yes, it's appearing.
Okay. So I have many tools related with AR and VR. At a few moments, we'll share with you some of these links to you to explore. But now I will open the 3D Bear, and I'm using my mobile phone with you. Also, you could use your mobile phone, but I will show 3D Bear. When you open the tool, you will see, let me just get the screen to the upper level. When you use the screen, when you open the tool, the first screen that you get is a welcome screen where you could see some work that the community of 3D Bear produced, and you could change to rights, and you'll see some sharing with your finger in your screen. You could just make the movement from left to right, right to left, and we will check some of the activities that was shared. At the bottom, we have five buttons that are the houses at the home screen where we are right now. The next one was a magnifying glass where you could search for some work from other people that are in community, or some themes and contents. The middle one, the green circle with the plus sign, will be the bottom where we will create our activity. The silhouette of a single person is our own profile, because when you are creating some activities, they will be stored in your profile. We are working at an online tool, so we don't lost any work that we are doing. And the last one, where you see some silhouettes of many people, are our class, where we could distribute, and inside the website of 3D Bear, I could create classes where I put my students and where they could share the work, or I could share the class activities, and so on. How can I start creating my activities? Just click at the green circle with the plus, and when you click in the green circle, you saw our real environment. You could see our computers and our specs that we have here in our desk. And at the bottom of the screen, you have many categories. Each one of these circles, where now I am at ABC 1, 2, 3, that are the category of letters and numbers. But if you scroll to right and left, you will check many activities, many categories of many 3D objects that I could use directly inside this situation. First one, from left to the right, is avatar. I could create my own avatar in 3D, 3D object that I could use here in the application, or could export for other applications. The next one, it's green with a down arrow, is to import some 3D objects that I produce in other tools. Also, I have here a direct connection to Sketchfab. Sketchfab is an online repository of 3D library, yes, of 3D objects that I could search and made the download for my 3D Bear tool, and use that 3D objects inside the tool, and so on. You could explore the next one, home, with some furniture that you could arrange to manage and build an house, plants and vegetation, learning space, basic forms, and so on. You could see, I will not explore all the categories, but you have here many categories with many 3D objects that could all right away explore and use in your own space. How can I construct some learning activity? Of course, before you go to this production, to go to create some product, some subject, some content, you must first of all give to your students a guide, an activity guide, for them to know what they have to do, okay? And after that, you gave them the freedom to make the storytelling, the digital narrative they want to create. Let's do something that will be transversal to all of us. Let's use some farm animals, for example. I have here letters, and letters are individually, or the first button where is the text at green. I could make a sentence, and I will click, and they will open my keyboard, and I will write farm animals. Okay. When it's done, I made okay. I saw my sentence right, farm animals, and to put this sentence inside in my real environment, I just have to click the green circle, and as you could see, I just have here my sentence in my real environment. So I have some problem connections.